Right. So currently, our focus in transportation, or the interest, is from primarily rail, and it's a combination of passenger and commercial. And basically, the idea there is to, I assume you're familiar with positive train control. This has been an initiative that the railroads have had underway for a very long time. Well, in addition to that, there's a whole host of other applications: line condition monitoring, weather rail crossings, automation of stations. So there's a whole group of applications that go beyond positive train control that are mission critical to rail and allow them to optimize the performance and basically monitor the quality of a rail in or trains in real time. And so that seems to be of high interest now. We're getting interest primarily from Europe. Really, our focus has been on commercial and transportation, rail transportation. And what we are seeing is that there's a real opportunity for industrial internet applications, along with new sensors that are being developed, really alongside the tracks, and for automation of the trains. So I'll just stop there for rail. In terms of other interests, we now have some interest on the general aviation side, where we have air-to-ground industrial internet applications that customers are pursuing, and we have some frequencies we have access to that could be applied to general aviation, where there's real-time connection to aircraft. So there's a whole host of transportation applications. We also believe that there's an application for industrial connected vehicle and autonomous vehicles, again, heavily focused in that case on a safety type network in the background to the general sensors and connectivity that they're using. So we believe that a lot of these applications for autonomous vehicles will need additional backup networks for security and reliability in the case of an event, a special event. So we're also pursuing applications related to that. It wouldn't be a primary network, but a secondary.
When you say a special event, what were you referring to?
Well, for example, in the connected vehicle, almost every one of the technologies that are used today are vulnerable to interference. So GPS is vulnerable to blocking, Wi-Fi, even the cellular networks are very vulnerable to interference for example, let's just take, if you were to take a section of a freeway and just, buy a $100 device at Radio Shack and set it up to jam frequencies along that section of the freeway, you could interfere with LTE, 5G, GPS, and anything Wi-Fi based, just creating interference to cause a problem. So we think that there's going to have to be additional redundancy in the connected vehicle, and a technology like ours could be used to preserve certain information and make sure it's distributed in a secure way. So again, we're in a very early stage of pursuing ideas like this, but it would be for redundancy and additional data in the background in the event of an emergency or some kind of event that was purposely implemented. So I believe that we are starting to see interest from cities for what you would call their mission critical applications. So a lot of the municipalities in the country have their own water and wastewater systems and critical applications that need to be secure at the local level. And we are now starting to see interest for our networks with cities, municipalities, for backup network connectivity. Let's say, for example, a city that's in the path of hurricanes consistently. they need a backup to the cellular networks for their mission critical applications. Many of the cities control pumping stations. Any city that is at sea level or slightly above sea level needs to make sure that their pumping stations don't go out, or they can be flooded. So we're looking at redundancy to some of their applications that have been impacted as they move more and more to wireless with the carriers. We also believe that they'll use our networks as primary in many instances to avoid the vulnerability to a commercial network. In terms of the network connectivity, I would say that just to summarize a bit, some of the things we're seeing is that with the advances in sensor technology, that's really driving more and more industrial connections at the edge of the grid and at the edge of any of these networks. And so we see that that's fueling a lot of the acceptance of our type of network to cover a very large area, very little infrastructure, and in fact, very quickly too. With right now, we operate a network in the metropolitan New York area, just with 4 of our base stations that covers roughly 20,000 square miles. So it's a kind of network that's available for critical applications at a very low cost and relatively quick to deploy. So yeah, but that's pretty much the summary.